so glad you've joined me. We are in the midst of our discussion of acids and bases, and in this video segment, I'm going to be introducing titration curves. At this point, we are at what I would call a level 1 section of titration curves. In another video, I will go into much more detail about titration curves, detail that's more appropriate for AP, IB, or college chemistry. So if you need an introduction, this is the place for you. All right, titration is a technique that is used to determine the unknown molarity of a substance. Now, it can be used for other purposes. To study different properties of acids or bases. But at an introductory level, it's often used to find an unknown molarity. So a solution of known molarity is added drop by drop, and we do that using a burette. So a burette has a stopcock, and you open it up, and it'll add a drop, or if you're really good, you can flip it and get like a quarter of a drop in there, a very, very small amount at a time. And so we would use a burette is the tool. And a neutralization reaction occurs. So for example, we could take HCl of an unknown molarity and slowly add NaOH until we had a 1-to-1 mole ratio of these. At that point, we've converted everything to salt and water, a neutralization reaction. Now, this solution is added. That point at which we have exactly that 1-to-1 mole ratio is called the equivalence point. Okay, and this is the point at which the acid is fully neutralized by the base, or conversely, a base is fully neutralized by an acid. Okay, when we've reached that, we've reached the end of the titration. But there's a problem with this. HCl, clear and colorless. NaOH, clear and colorless. Sodium chloride, clear and colorless. I hope you get the idea. You know, everything just looks like water being added to water. So how do we know when we're at the end? Well, that's where we would use an indicator. Now, you could use a pH probe. That's a little slower but gives much more detail. Typically at a first level of learning, we would use an indicator, something that changes color with pH. Phenolphthalene's a good example, but there are dozens of them. Litmus, universal indicator. There's methyl orange, methyl blue, thymol blue. There's just so many of them. And they all change color at different pH values. So we can pick the one that's convenient for our particular pH. Now, when that indicator changes color, we call that, so when the indicator changes color, it's called the end point. And your goal is that the end point is as close to your equivalence point as possible. Okay, so that that's how you're going to know that you've got full neutralization. If it changes color too far from the equivalence point, you're going to add a lot of error to your titration and your molarity determination. So let's take a look at what these titration curves would look like. So on this, So on this one, let me see if I can draw this a little neater. So I would be measuring pH, and here would be pH 7, and I would add volume of base. Or I'm just going to look at hydroxide because I don't really care about this sodium ion. It could have been potassium hydroxide. Just needs to be a strong base. Okay, and then this is 0. And I'm going to be titrating an acid, so it's going to start at a very low pH. And as I add my hydroxide, as my volume, when I reach the equivalence point, my titration curve will shoot up and then level off. Okay. Now this shape is indicative of a strong acid plus a strong base. Okay. If I had a weak acid, it would start higher, go up a little bit, level off a little bit. The equivalence point would be a little bit broader, and then it would level off here. Whoops, it should level off identical. I didn't do a good job of that. There we go. And the equivalence point is going to be basic. Okay, and this would take the same volume of base, assuming they were the same molarity. Just wanted to give you an idea of the shape there. If we did a base with acid, so if I added HCl, HNO3, some strong acid, and I have pH, now bases are going to start high. If it's strong, it would be flat with a very sharp equivalence point. I'll try to do a better job this time. I wanted you to draw it. If it's weak, it's going to drop down, level off a little bit, and then reach its equivalence point there. Okay? So if they're the same molarity, they'll have the same volume of acid at the equivalence point. Now, if we had a polyprotic acid, what you would see is you would see an equivalence point for each proton. Okay, this would be a shape that you would see for a diprotic, two protons acid. Okay, so hopefully that gives you a nice introduction to titration curves at an introductory level. Thanks for joining me.